Okay, let's learn quickly how to do transformations. So building on what we learned the other day, we learned how to graph y equals 2 to the x or 3 to the x. Anytime a was bigger than 1, we learned how to graph that graph. E is approximately equal to 2.718, right? So, which is a little bit bigger than that. So the basic parent graph is pretty much the same. We've got y equals 0. We've got a point here at 0, 1. And the basic graph looks pretty much like this. It's going to be an exponential function, approach the asymptote on the left, and it grows really quickly. Now, if you want to get a bonus point, I want you to plug in another point here. So if you plugged in, say, 1, let's see what that would do. 1, comma, let's see, plug in 1 there for x, and you get e to the first, or e, would be the ordered pair of that point. I actually don't have that at the right spot. If you think about it, I should have drawn that graph if I'm trying to graph this accurately. E is 2.7, so if I want to graph that accurately, it would be 1 comma 2.7, somewhere up there. And so then we could draw the graph and connect it. And so it goes up a little faster than I thought there. But that's your basic parent graph. And again, if you want to show another point, obviously the main point we're showing here is 0, 1, which is true for most exponential functions. Transformations work the same way. So if you start with y equals 0 here, again, we're graphing, just sketching it out. It's more of a sketch than a pure graph here. And so if we plot the point 0, 1, the parent graph looks kind of like this. You got it? This is going to move the graph a couple different things here. So this is going to take the graph, because it's in the parentheses there, x minus h. So it's going to go to the right 2 units, and plus k is going to move up 1 unit. So I take the line, the asymptote is now going to be at y equals 2. The point is going to move 2 units to the right and 1 unit up. It should be at about, I moved the asymptote to the wrong spot. Sorry about that. I can correct that. That's okay. So the asymptote moves up 1 unit, which would be to here at y equals 1. I knew it was wrong because my point can't be on the asymptote. I take that point at 1, 0, move it 2 units to the right and 1 unit up. So now it's at 2, 2. And the graph is going to approach the asymptote on the left. It's going to hit that point and boogie on up. It's going to grow really quickly, exponential growth there. If you want to plug in another point, we could try a point right here. So that would be like 1 comma, let's see, plug in 1 there. That would be 1 minus 2 is negative 1. So e to the negative 1 plus 1. I would write it this way, 1 over e plus 1. Transformation here. Start with the parent graph, y equals 0. So plot goes to the point 0, 1. Parent graph does this, grows really quickly. So this is going to do two things. This is going to stretch the values by the y values by a factor of 1. So it was at 0, 1 here. We're going to multiply that by 2, so we get 0, 2. So that's the new point. The asymptote is still at y equals 0. That doesn't change. And then this one is going to reflect across the y-axis. So take the graph and reflect it across the y-axis because it's attached to the x there. So instead of increasing, it's going to decay. So exponential decay. So it's going to hit that point coming on the way down, and it's going to approach the asymptote on the right as x goes towards infinity. And that's just your quick recap of graphing exponential functions with the natural exponential function.